Consider the function gx is equal to negative 2x cubed plus 6x squared plus 18x minus 7. Part A. Find g dash x and draw sign diagram. Gradient function. Find intervals where the function is increasing and decreasing. Find and classify any stationary points. Describe the behavior of the function as x approaches infinity and x approaches to negative infinity. Hence sketch the graph. Given curve z of x is equal to negative 2x cubed plus 6x squared plus 18x minus 7. The first part of the question is find gradient function. So differentiate with respect to x, everybody knows that. Factorize negative 6 x squared negative minus 2x minus 3 x minus 3 into x plus 1 as the factors. We can draw the sign diagram for this gradient function g dash. So negative 1 and 3. So we can check the sign on the left side. If you look at the left side of negative 1, the gradient is negative. Gradient is negative. On the right side of negative 1, gradient is positive, as well as on the right side of 3, the gradient is negative. So therefore curve is increasing. Therefore g is increasing on negative 1 to 3 and decreasing on minus infinity to negative 1 union 3 to infinity. Find and classify any stationary points. So for stationary points, gradient means, when we say stationary point means tangent is horizontal and gradient is 0 over there. So therefore g dash x is equal to 0. That implies negative 6 into x minus 3 into x plus 1 equal to 0. So that implies there are 2 points, x is equal to 3 or x is equal to negative 1. But what is the nature of these stationary points? We'll use first derivative test as well as second derivative test. Let's use first derivative and double derivative tests to identify the stationary points. Okay, so when x is equal to 3, choose very close to 3 on the both sides, neighborhood of 3, 3.1, choose 3.1 which is greater than 3, and therefore g dash 3.1 will be negative, means gradient will be negative on the right side, negative, and choose x is equal to, let's say, 2.9 on the left side, very close to 3 on the left side, which is less than 3, and the gradient at 2.9 will be positive. So for smaller values gradient is positive, for bigger values gradient is negative. Therefore x is equal to 3 will give us is a point of maximum. So what is that? Coordinates. Substitute x is equal to 3 in the given curve and the corresponding y value will be 47. So that's the first derivative test. Is a bit easier than first derivative. So we differentiate again g double dash x. G double dash x will be negative 12x plus 12. So when x is equal to 3, sign of the double derivative at 3 will be negative. So therefore x is equal to 3 is the maximum point, and the corresponding coordinates will be 347. When x is equal to negative 1, we can use first derivative test first, or the sign diagram can also be very helpful. choose x is equal to negative 1.1 on the right side of negative 1, on the left side of negative 1, which is smaller than negative 1, and g dash at negative 1, as we have seen with the sign diagram, is negative for the smaller values. Okay, here. So choose second on the other side, once over here closer to negative 1 on the both sides. X is equal to negative 0.9, which is greater than negative 1. G dash negative 0.9 is positive from the sign diagram. So therefore x is equal to negative 1 is the minimum point. And what are the coordinates? When we substitute x equal to negative 1 in the given basic curve, we will get negative 17 value of y, the first derivative test. Let's see the same with the second derivative test. Second derivative test for the second minimum point, for the minimum point. Again, double derivative at this point. Double derivative we have already seen in the above. Negative 1 will be equal to, if you substitute the values, the double derivative, that will be equal to negative 2 into negative 1 plus 2, that is equal to 4, which is positive. So when double derivative at that point is positive, that means therefore x is equal to negative 1 is the minimum point. If x is equal to negative 1 gives the minimum point. So when x is negative 1, negative 17 is the corresponding minimum point. Describe the behavior of the function as x approaches to infinity and as x approaches to negative infinity. So if it is a paper 2 question, we can simply draw the curve and sketch the function. So we can try the sketching the graph. So as x approaches to infinity, what will happen to y? Y will approach to negative infinity. And as x approaches to negative infinity, y will be approaching to plus infinity. E part. Now if you sketch it, x-axis, y-axis, by mentioning the important features, somewhat like this. X-axis, here minimum point, here we have the maximum point, curve is zx, and you see here as x is approaching to infinity, this curve is going downwards towards negative infinity, and here as x is approaching to negative infinity, the y is approaching to, the curve is going upwards. So we can relate it that way also. Maximum point 347, some like this way. So therefore that's the answer to this question.